Okay, so I have a little more time today to work, so I'm going to take advantage of it and do the um, fixed XOR implementation. So between sessions, I wrote a bunch of helper functions for me in dataweave for converting between uh, hexadecimal and uh, binary and hexadecimal, um, base 64 in binary and base 64. So that gave me a nice little from hex to base 64 function here. So I'm going from hex to binary, taking that binary, formatting it for base 64, and then going from binary to base 64. Same thing for hex to binary, or from I haven't got a base 64 to binary yet. I have hex to base 64. Do I have binary from base 64 to binary? I haven't implemented that one yet. That'd be a good one to do next. But yeah, I got some helper functions for going from hex to base 64 right now. Um, and so now we're gonna do the next challenge, which is doing a fixed XOR algorithm. So what this does is it takes a hex, converts it to binary, takes another hex, converts that to binary, and then does the XOR algorithm against it, takes the result of that and converts that to back to hex. So for the XOR, it's we can XOR algorithm. We can look at what that does. It's a cipher that just says, yeah, here's some examples. So if they don't match, it's 1. If they do match, it's 0. If they don't match, it's 1. If they do match, it's 0. So it doesn't care whether it's a 1 or a 0 as long as they're the same at that same bit in the string or um, in the binary number, the same bit. If they're the same uh, value as the comparison and the key, then it puts it as 0. If they're different, then it puts it as 1. And then that way, as long as you have the same key, you can convert it back in the other direction. So we're going to write that now, taking advantage of some of these functions. So we're going to use our hex to binary to convert a string to binary. We're going to go through all of that with our XOR, and then take that binary and convert it back to hex. So, so we'll do this first. We're going to do, also we'll do. We're going to have a couple of variables. So var variable is going to be, let's see, uh, let's see, how do they word this? Explain when you feed it the string after hex decoding. So, oops, I didn't want to do that. So we'll do hex string, and this is going to be a string. So var binaries, binary input equals hex string. Let's see, imports, let's see, hex to binary, or from hex to binary. Yep, hex string, right? And then var secret, binary secret equals from hex to binary secret. And then we will then have two arrays of binaries, which we can just join. Well, so why don't we just do that? So we'll just join them here. Join by that and join by that. And then we will say let's see, we want to convert those to an array of characters, right? So split by that. So we're going to join them and then split them. Split by that. So that gives us two arrays of characters, right? And then we will zip those, right? So zip binary input and binary secret. We should write tests before we do all of this. Let's comment this out and write a test. Command K, Command C. Let's just comment the whole thing out. Command K, Command C. Let's write a test. Add unit test. Do we want to make this into a folder? Oh, it already did. Good. Okay, created the algorithms folder. So import from algorithms XOR. Good. Awesome. Fixed XOR. It should fixed XOR apply fixed XOR algorithm when given a hex and equally long secret. Given a hex, string, an equally long hex secret. So if we have an example, so what's the hex for that? 0101 0111. So that's two things, right? I look in here. So that's 5. And so 0101 and 0111. So 57, right? 57. That's the two characters, 5 and 7. Right? So if we as hex, so if we did 5 7 and this is 1111 and 0011, so F and 3, so did F3, all right. And then it needs to return must equal to, and then it needs to be a string of 1010 A and 0100 A4. Okay, so it's going to return an hex of A4. Okay, so 5.3 converts to must equal to A4. Okay, cool. So if we just do this first, right, we'll just write a test that passes A4. Make sure we've got our basic structure, right? Boo, boo, boo. And then we'll write a test for this one, right? Okay. So it applies a fixed XOR algorithm when given a hex string of 0, 1, 1, 0, 0, 1, 1, 0 is 6, and 1, 0, 0, 1 is 9, so 69. Close this file. 69 and a secret of F3, right? And do fixed XOR 69 F3 must equal to, and in this case that will be 1001 and 1010. So 9A. 9A. Okay. This is a failing test. And while we wait for that test to fail, we're going to go work on, we're going to go work on an implementation. Okay, so let's go look at what we had written here, commented out. So we've got binary input, blah, 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 split by, zip. This is mad because I'm returning an array of strings, but that's fine. We'll fix that on the other end because we're going to reduce over that, right? Zip that. And then we're gonna reduce it with a pair and an accumulator of we'll just do a string. Right, and then we'll say if pair 0 equals pair 1, then we will give it a 0, else we are going to give it a 1. Right? Oh, we want this to be a string. 0 or a 1. Okay. Let's move this down here. Clean it up. Okay. All right. So we've got our. No, I don't like that. Let's put our if statement on the new line. If this, else this, 0, 1. There we go. All right. So we've got that. And then we're going to add a then. Oh, it's ACC plus plus and ACC plus plus, right? Then binary. We're going to substring that. We do import substring every from strings. Substring every binary. What's our length for binary to hex? So do we have, what's our binary to hex function do? From binary to hex. Oh, we're already doing the substring already. We just give it an array of strings. So I think that'll work. We can just wrap that. That'll substring every 4, and then that'll write pad, and then that'll do that. I think we can just do that. So we just give it an array of strings. Yep. So, and it's data, it's an array of strings from a place, so we can just do this. We don't even need to do this. We can just say then. Binary from binary to hex. That. Right? Yep. Let's see if that works. Worked on the first try. Look at that. So if that's correct, then we can write our more complicated test. We want to say it applies a fixed XOR algorithm. I'm probably saying that algorithm name wrong. When given a longer hex string of, let's fix our spelling here, string of longer hex string and secret and do fixed XOR that and that must equal to that. Let's see if my helper functions and my algorithm work. So this works on the first try. Watch, it won't. It won't work on the first try. Nothing I do ever works on the first try. I probably have some like deep, complicated screw up that I'm not thinking about. Look at that. See? Expected it to be 7486. Okay, what do we C. Oh, um, I just need to upcase this, right? Because we're upcasing, so upper this. We're upcasing our hexes, right? Because why not? Okay. If this works, it looked like it was going to work. I think the only difference. Look at that magic. Just casing. All right. So we solved that in like very little time. I am going to cut it off there though because I have to go get a kid from the bus stop. But when we get back tomorrow, I am going to work on the next crypto challenge, which will be a single byte XOR cipher. Find the key, decrypt the message. Just gonna don't write code to do it. So some method for scoring. So we're gonna try to figure out what character this was XORed by and decrypt the message. Some method for scoring a piece of plain English text. Character frequency is a good metric. Evaluate each output and choose the one with the best score. Ooh, we're gonna be able to take advantage of some of the we're gonna be able to take advantage of some of dataweave's libraries for that, but we'll do that tomorrow. Cool. So that's a good stopping place for us. And folks, have a good night.